Now, in today's session, we will study about the chemical reaction of carboxylic acid. Carboxylic acid. Carboxylic acid reacts with a reactive metal to liberate hydrogen gas and forms salt, sodium carboxylate is formed. Just like alcohol, it also reacts with sodium hydroxide to form sodium carboxylate and liberates water. It also reacts with the weak bases like carbonates and bicarbonates, unlike alcohol and phenol. Unlike phenol, not alcohol, unlike phenol, it forms salt, water and carbon dioxide. This reaction is used as a test for carboxylic acid. Test for carboxylic acid group. So in the question is asked, how will you distinguish between phenol and carboxylic acid? Then we can use sodium bicarbonate test. It liberates the brisk effervescence of carbon dioxide. Now carboxylate ion dissociates in water to form carboxylate ion dissociates into water to form carboxylate ion and the hydronium ion. Plus water, it forms carboxylate ion and hydronium ion. This carboxylate ion exists as a resonance hybrid of two structures. This carboxylate ion exists as a resonance hybrid of two structures. Therefore, this can be written as R dotted line represents resonance. Sometimes the negative charge is represented on this or sometimes on this oxygen atom. Now if we apply law of chemical equilibrium on the above reaction, then K equilibrium will be equal to active mass of carboxylate ion into hydronium ion divided by active mass of carboxylic acid and water. This can be written as Ka will be equal to Keq into H2O is equal to RCOO minus H3O plus divided by RCOOH. So Keq is the equilibrium constant, whereas K is the dissociation constant for acid. Ka is the dissociation constant for acid. Now, the strength of the acid can be indicated by pKa. pKa is equal to minus log Ka. The strength of an acid can be indicated by its pKa value rather than Ka value. pKa value is equal to minus log Ka. Now, smaller the value of pKa, stronger is the acid. Smaller the value of pKa, stronger is the acid. For example, acetic acid has 0.23 pKa value. Benzoic acid has 4.19. Acetic acid has 4.76. So, and HCl has -7. So, from the above these values we can arrange them in increasing order of acidic character. It means the acetic acid is lowest and HCl is the greatest in acidic character. Strong acid has pKa value less than 1. Moderately strong acid has between 5 to 15, and weak acids greater than 15. Now, next comparison of the acidic character of carboxylic acid with other compounds. Now first question is, carboxylic acids are weaker acids than mineral acids because of the lesser pK value. Number 2, they are stronger acids than alcohol as well as many simple phenols. Now the high acidic character of carboxylic acid than phenol is due to the conjugate base of carboxylic acid. A carboxylate ion is stabilized by two equivalent resonant groups. The carboxylate ion formed is stabilized by resonance. Now its resonating structures are so these two structures, the carboxylate ions are resonance stabilized by these two structures, in which the negative charge is present on the more electronegative oxygen atom, whereas in the case of phenol it is not stabilized by resonance. Therefore carboxylic acids are stronger acid than phenol. Number 2, the negative charge is delocalized over two electronegative oxygen atoms in the carboxylate ion, whereas it is less effectively delocalized over one oxygen atom in the phenoxide ion. So two reasons are there for the greater acidic character of carboxylic acid. Now next is effect of substituent groups. Substituent groups on acidity. Now electron withdrawing group stabilizes the carboxylate ion, and strengthen the acidic character. Strengthens the acidic character. That is, if nitro group is attached, then the acidic character will increase of the carboxylic acid, whereas electron donating group will destabilize the carboxylate ion and weakens the acid. Now the order of acidic character the order of acidic character of the different functional groups. Now, phenyl group, order of increasing acidic character. This you should learn it. Phenyl group is less than iodide group, less than bromide, less than iodide, less than chloride, less than nitrile, less than nitro, and less than tri-substituted carboxylic acid. Now, second point is, with increase in number of halogen atom, acidic character increases. With increase in halogen atom, acidic character increases. For example, CF3COOH will be CHF2COOH will be greater than CH2FCOOH and will be greater than CH3COOH. Second point you can write down, that is, with the distance from the carboxylic acid, from the carboxylic acid acidic character decreases. For example, CH3COOH is less than C6H5CH2COOH. So we can see here the distance is, one more example you can write down, CF3CH2COOH. So in between carboxylic acid, the group CH2 group has increased. So with increased distance, the acidic character increases in the following order. Next is direct attachment of group like phenyl and vinyl group to the carboxylic acid increases the acidic character. The direct attachment to the carboxylic acid groups like phenyl or vinyl group, acidic character increases, and this is because of greater electronegativity of sp2 hybridized carbon to which carboxylic carbon is attached. Again, the presence of electron withdrawing group will increase their acidic character, and electron donating group will decrease the acidic character. For example, CO OCH3 electron donating group. So it will decrease the acidic character, and if we add nitro group, this is electron donating group, this is electron withdrawing group. So this will decrease the acidic character, and this will increase the acidic character. Next is chemical reactions involving cleavage of COH bond. So first is dehydration. Cleavage of COH bond. Now under it, formation of anhydride. When two molecules of carboxylic acid undergoes dehydration in the presence of the dehydrating agent P2O5, phosphorus pentaoxide, then it forms acetic anhydride. It forms acetic anhydride. Here we can write down acid anhydride. Second example is, that is esterification. Now esterification, when carboxylic acid reacts with alcohol in the presence of concentrated sulfuric acid, it forms ester, a sweet smelling compound. We can also take dry HCl gas as a catalyst, or dry HCl gas as a catalyst. Next is reaction with PCl5. Third is reaction with PCl3, PCl5 and SOCl2 thionyl chloride, RCOH carboxylic acid plus PCl3, it forms RCOCl plus H3PO3 hypophosphorus acid. Now second is, when carboxylic acid reacts with PCl5, it forms RCOCl plus POCl3 plus HCl. And third reaction is carboxylic acid plus thionyl chloride. It forms RCOCl, acid chloride plus SO2 plus HCl. The next is reaction with ammonia. Carboxylic acid reacts with ammonia to form ammonium acetate. Reaction with ammonia, carboxylic acid reacts with ammonia, forms ammonium RCOONH4, ammonium carboxylate, ammonium carboxylate, which on heating forms amide RCONH2. Amide, here R may be alkyl group or aryl group. Means here R may be CH3 or C6H5. Now next is, if two carboxylic acid groups are present with the benzene ring, it is called phthalic acid. It is called phthalic acid. It reacts with ammonia to form ammonium phthalate. Ammonium phthalate, which on heating forms phthalilamide CONH2. Phthalilamide, which on strong heating its name is PHTHALAMID, phthalamide, which in strong heating forms CONH, and it is called phthalylamide, PHTHAL. This is AMIDE and this is IMIDE, phthalylamide and thil. Now next is reaction involving COOH group. Reaction involving COOH group. Reaction involving COOH group. Under it, first is reduction. Carboxylic acid undergoes reduction to form alcohol in the presence of strong reducing agent lithium aluminum hydride, followed by acidic hydrolysis. It forms alcohol. Carboxylic acid in the presence of strong lithium aluminum hydride, it forms alcohol containing same number of carbon atom as it was present in carboxylic acid. Number 2, decarboxylation. Now decarboxylation, that is removal of carbon dioxide. When sodium carboxylate is heated in the presence of soda lime NaOH plus CaO, they are called as soda lime. It forms alkane. This reaction we have studied in class 11th. This reaction is also known as coal-base electrolysis reaction. Coal-base electrolysis. Now, if you will electrolyzed then it forms alkane. Plus CO2 plus H2 plus NaOH. So this reaction, when sodium carboxylate in the presence of NaOH plus CO, there also removal of CO2, here also removal of CO2, but here it is electrolyzed to give you alkane. The only difference in these two reactions are that in coal-base electrolysis reaction, the number of carbon gets doubled. Electrolysis reaction, the number of carbon doubles to the carboxylate salt. By this method we can also prepare alkene and alkyne. Next is substitution reaction in the hydrocarbon part. Substitution reaction in the hydrocarbon part. Substitution reaction in hydrocarbon part. Now carboxylic acid RCH2COOH when reacts with chlorine in the presence of red phosphorus followed by hydrolysis, the alpha hydrogen is replaced by halogen. The alpha hydrogen is replaced by halogen. This reaction is known as Hell-Volhard-Jelensky reaction. Zelinsky. Hell-Volhard-Jelensky reaction means in the second step again this hydrogen will be replaced. So only the alpha hydrogen atoms are replaced. Next is ring substitution. Ring substitution. Under it, first reaction we will study, that is nitration. Now carboxylic acid is meta-directing group, so the incoming group will go to meta position. So it will form meta-nitrobenzoic acid. It will form meta-nitrobenzoic acid. Second example is bromination. Benzoic acid reacts with bromine in the presence of Lewis acid, FeBr3. It forms metabromo benzoic acid. Now the carboxylic acid, that is benzoic acid, it do not undergo Friedel-Crafts reaction because the COOH group is deactivating group and it combines with the catalyst AlCl3 to form a salt. So therefore it do not undergo Friedel-Crafts reaction. This question is asked in board. Next is uses of carboxylic acid. Methanoic acid is used in rubber, textile, dyeing, leather and electroplating industries. Ethanoic acid is used as solvent. It is also used as vinegar in food industries. Hexane dioic acid is used in the manufacture of nylon 6,6. Astrobenzoic acids are used in perfume industries. Sodium benzoate is used as food preservative in squash. Higher fatty acids are used in the manufacture of soap and detergent. So in this session we have discussed about the chemical properties of carboxylic acid, in which We have discussed the acidic character and the different chemical reactions and uses of carboxylic acid.